Ladies and gentlemen, may I have your attention, please?
Good morning all. I am Ashok Shinde from Redline Controls. On behalf of Redline, I would like to thank you all for attending this session. Also, I would like to thank IIT Communication for arranging such interactive event. Industrial data for seamless IT and OT convergence. While implementing Industry 4.0, it is required to give attention to IT-OT integration. IT-OT convergence is the integration of the intelligent part of the company, the IT, with the operative part of the company, so-called OT. Redline products are used for seamless integration of IT and OT. In today's session, I'll be talking about the Redline solution in seamless integration of IT and OT. So let's start. History of innovation. Redline Control is a part of Spectris PLC, the expert in providing insight through precision measurement. Redline has been delivering innovative solutions to global market since 1972 through communication, monitoring, and control for industrial automation and networking, enabling companies worldwide to gain real-time data visibility that drives productivity. Milestones. Redline is founded in 1972. In 1976, the end-to-end process display added in our product portfolio. In 1996, the Redline acquired a company called Paradigm Controls. With this acquisition, it is added HMIs, which is used to connect to multiple devices via serial or Ethernet connections. It helps for broadening monitor and control capability. In 2010, we acquired a company called Entron. With adding Entron, it added industrial Ethernet switches and providing integrated solutions that reach from the enterprise networks to the plant floor. In 2011, Redline acquired 6net. With adding 6net, it helps to expand industrial Ethernet offering and adding cellular M2M and remote telemetry units to control and monitor complex process in extreme location. 2013, the hardened modular HMIs have been added in our product portfolio. 2018, the new product that is DS series added for data acquisition and IoT gateway, which helps for effortless IoT implementation. 2019, the Ethernet switches added, which is layer 3 product and which is help for broadening the Ethernet product portfolio. In 2020, The Flexes product helps for taking IoT to the edge and beyond. Also in 2020, the new switch, that is Profinet switch added, which is gigabit option. 2020, one more product is added for strengthening the IoT range, which is called secure remote access device. Redline at a glance. In a Redline product portfolio, we have industrial networking, industrial automation, and edge controlling products. Industrial networking portfolio, we manufacture industrial Ethernet switches. Those are used in different verticals such as oil and gas, manufacturing, alternative energy, power and utilities, transportation, water, and wastewater. Redline provides Entron and 6net Ethernet switches, cellular MTM devices, and communication converters to address a wide range of industrial networking requirements. From remote site management to industrial process control, our industrial networking products are designed to operate reliably in harsh environment. Unmanaged switches. Redline's unmanaged industrial Ethernet switches offer simple plug-and-play functionality with reliable performance. Available in an endless range of port options, our rugged switches are set to tackle the demands of industrial data acquisition, control, and Ethernet I/O application. Monitor switches. Redline offers a wide selection of Ethernet switches with monitoring capabilities, providing the simplicity of a managed switch and advanced remote diagnostic capabilities. Our monitored switches perform in harsh environment and offer ease of deployment. Our monitored switches are part of one managed switch, but using with NVM software, it gives option of switch data monitoring. Managed switches. Redline offers a wide selection of managed industrial Ethernet switches that provides the ability to configure port setting, manage network traffic, and remotely monitor network for critical issues. Our managed switches are designed to operate in harsh environment and offer best-in-class performance and mission-critical application in which security, environmental features are the preference. Redline's NT4000H, which is 8-port gigabit managed Ethernet switches, are certified to meet Profinet Conformance Class P. QE switches. Redline's wide range of industrial QE solutions are designed to transmit power and data over Ethernet, which helps for eliminating the need to run separate cables, saving time and money. Routers. Redline's industrial wired routers offer secure and reliable communication to remotely deployed assets. Our industrial routers are ideal for connecting Modbus or DNP3 enabled devices such as SCADA servers, PLCs, and other automation equipment with remote locations. IP67 and OEM boards. Redline offer a wide selection of IP67 and OEM embedded switches for the harshest environment. Available with unmanaged layer 2 management features, gigabit speed, PoE, and bypass relay options. These switches provide a robust solution for high vibration and mission critical deployment. Cellular RTUs. Redline's industrial cellular RTU provides a secure all-in-one platform to remotely connect, monitor, and control assets. Industrial automation. Redline Control offers a wide variety of automation products that support a full spectrum of industrial application. From factory automation to process control, our product address a wide range of industrial requirements. In industrial automation product portfolio, we have data acquisition product to use in automation application. Our acquisition products are used in IoT applications. Redline product supports with high temperature, shock, and vibration to withstand in critical applications. PID controllers. From single to multi-loop control, Redline has the right PID controller for any application. Our wide range of PID controllers are rugged, reliable, and easy to deploy. Data acquisitions. Redline provides high performance, feature-rich data acquisition solution with native support for over 300 industrial protocols, optional cloud connectivity, OPC UA server, and client functionality, modular communication, scalable I/O, and optional multi-zone PID controllers. Redline's Flexage Industrial Edge Automation Platform, Data Station, and rugged graphite edge controller all simplify integration. Industrial controller and RTUs. Redline's industrial control products range from a rugged controller and modules that features IC61131 control. IO models. Our 6net series E3 IO models and EtherTrack 2 IO models provide a simple aid, powerful monitoring, and control system for remote site. Signal conditioners. Our broad selections of signal conditioner which work with frequency, temperature, and process application range from dedicated to universal models capable of accepting over 100 inputs. Sensors. Redline provides analog, digital, and other process-specific sensors that work in conjunction with HMIs, panel meters, IO modules, and controllers. HMI operator panels. From factories to extreme remote locations, our HMI solutions enable customers to easily connect, monitor, and control processes across a diverse range of industries that includes manufacturing, oil and gas, and water, wastewater. Panel meters. Redline offers the widest range of panel meters in the industry. Our meters are available in various sizes and capabilities, including count, rate, time, voltage, current process, strain gauge, and temperature input. Large LED displays. Our large LED display offers multiple input and optional output cards to meet a variety of visual display needs, available with up to 4-inch tall characters. Visual management devices. Redline's productivity station is ready to deploy plant floor visual management system that displays real-time key performance and on message on large televisions to drive efficiency. Edge controlling. Redline's Flexage Secure Edge Networking Gateway and Industrial Pro routers offer reliable connectivity to deployed assets. Ideal for harsh environment, these rugged devices offer secure communication between SCADA, servers, RTUs, PLCs, remote IOs, and other connected devices such as remote cameras or industrial sensors. Access of IT to OT data. Challenges. So we observed when we access the IT to OT, there are certain challenges what we are facing. Challenge 1, OT-IT divide. While integrating IT to OT, we observe some challenges such as synchronizing data at both OT level and IT level that will help company in order to work efficiently. The IT-OT divide. The IT-OT divide is the challenge of managing industrial assets and their operational uptime with the infrastructure and teams required to keep the system operating smoothly. The divide comes from a variety of different areas, but ultimately, it is rooted with a set policy. For example, hopefully we can recognize that our automation engineer can own, deploy, operate, and maintain the PLC on the factory floor. However, as these devices are now connected to industrial Ethernet networks, the struggle for who owns the PLC, the hardware or software configuration is becoming unclear. This concept of connecting more assets and moving data is what is blurring the line between asset owners. IT-OT divide, goal misalignment. If we look at the OT-IT divide, another way we can break down the responsibilities of each department. While the overall goal of both departments may be to keep the company productions goods, each team has very different approaches to achieving that. IT is typically responsible for security accessibility, network reliability, and scalability, whereas OT is in charge of production uptime, throughput, efficiency, quality, and safety. As we continue to connect more automation equipment, the line of who is responsible will continue to be moving. One team is responsible for the hardware and other responsible for how it is configured, how the accountability is established. Challenge 2. The next challenge is production architecture transition. The equipments we use currently should evolve with the next technologies. Current equipment should be capable to use future technology. These are the certain challenges what are observed in most of the verticals. The production architecture is changing from pyramid to an agent-based control architecture. In pyramid-type architecture, devices are connected to the nearest upper level. There is no option to communicate from bottom level to directly with top level. It has to follow the level steps. But as per the current architecture of agent-based, input signal can now communicate directly with the ERP, cloud, and SCADA. The production architecture, it is the red line difference. Red line hardware with Crimson solution supports to connect all different levels of architecture. It connects to the input-output signals because of the onboard I/O connectivity. It also connects to various devices and it has got 300 different protocols for connecting end devices, including various PLCs. It helps as one solution for connecting different levels. Redline products in data acquisitions are used for harsh environment application. Crimson programming software used with automation product supports GUI-based configuration. In multi-protocol conversion, single device gets connected with 20 simultaneous conversion. Also, with the new technology of IoT, the data is now ready to send directly at cloud systems. Here is the window of Crimson software. The software is available to download from Redline website, and we do not charge for this software. You can see the graphical based configuration window of Redline software. Flexis controller with Crimson 3.2. It's an intelligent edge automation platform brings industrial data together as never before to transform edge computing. FlexEdge provides a scalable solution to integrate complex multi-vendor environments into digital transformation strategies while providing a future-proof solution for changing application needs. It supports more than 300 protocols. Also, addition to that, it's more than 1,000 combination with using Ethernet, serial, and various connection options. Also, it has got rugged design and also comes with certain certifications that includes UL, EX, ICX, ABS, and DNV. How the Flexis controller with Crimson 3.2 used in the OT environment, operational environment. We all know for the OT, there are end devices need to be connected. And also, it has to send data to the remote location. Now for OT connection, it used for aggregating and analyzing of data from the remote devices. Use functions of SMS notification, which is used for remote monitoring. Data controlling and monitoring for non-compliant data values. PLC data will be accessed. PLC will be connected on Ethernet port or serial port. Hence, the data will be accessed from Flexis device. How it helps for IT. Other side, Flexis supports SCADA connectivity, MES connectivity, and ERP connectivity. Since the data is connected on the one side, on the hardware, the data will be then sent to the other side using certain protocols. Also, it has got pre-configured cloud providers such as Azure, Google Ignition, Amazon AWS, Unidarts, and Sparkplugs. Comes with the security functionality, which is used for secure remote access. Flexis controller platforms. On the left side, you see the DA50, and the right side, it's DA70. So in Flexis, we have two different platforms. One is DA50 and DA70. The DA50 feature one communications layer and onboard I/O. Variety of serial and Ethernet ports enable easy integration to any applications. The modular design of the DA70A allows for up to 3 communication slates to be added as requirements change or new communication standards emerges. Rugged field installable PID controls and IO modules ensure a solution that adapts to meet almost any industrial application need. Flexis scalability. Software-defined gateway, field upgradable. Select the right Flexis software functionality for the application. Select from networking gateways, protocol gateways, advanced IoT gateways, and automation controller with IC 61131 capabilities. If the application changes, simply upgrade the gateway to meet the application requirement. It's that easy. Reduce or eliminate costly equipment changes as simply as pushing new software. Secure remote access platform. Redline has been selling remote access for years, but the one component that has been missing is a Redline managed remote access server. Customers find this too much of a hassle to manage their own servers. Redline gives them a remote access solution with the complete IoT solution. The Redline remote access platform delivers next generation remote access solutions to meet the most intense high equipment management, allowing to quickly respond to and act on most crucial data from anywhere. With the ability to remotely access, monitor, and maintain the diverse equipment, you can lower operational cost and downtime while opening doors for new revenue streams only made possible by secure IoT. And because Redline's secure remote access solution offers true plug-and-play simplicity, setup is lightning fast for even high-value deployments. The RL Connect 24 and RL Dial-up softwares are used for accessing the remote access devices. VPN client is the function which is used for connecting the remote devices. RL Connect 24 is the cloud portal and it is used for central point access. RL Dial is installed in the computer and which helps for establish secure connection through RL Connect 24 to remote access device. Remote access router, which supports the QR codes for quickly enable remote accesses. All-in-one IoT solutions. VPN tunnel makes it possible to work just as if you are located to do things like view the virtual HMI. So make software changes to industrial equipment and troubleshoot issues. Two different ways to consume the data, that is at the remote side, VPN connection via RL dial-up and viewing dashboard from the browser. Remote access and data collection. So there are three different devices in the remote access platform: RA50C, RA70S, and RA70K. So each device has got certain features. So RA70S it supports IPsec, L2TP, and PPTP. Those are the VPN connectivity. RA70K, it has got the function of key connection so that it will be used for security at the site location. Unyielding security. Redline's secure remote access solution have been designed from the ground up with an unyielding emphasis on security. This means now you can focus on your business and bottom line instead of worrying about whether your data and assets are protected. Intelligent firewall monitors the communication and learning modes for more security. Configure with just a few clicks or tabs for a quick user-friendly experience. Safeguard applications with cybersecurity at the highest level. Take advantages of multi-stage user level and secure boot concepts. Here we have some customer references. On the left side, the very first is Blizzard Sky Manufacturing. They are the Crimson products with productivity station is used here for collecting data from existing system. That helps them for minimizing the production downtime. Crimson Flexes Gateway with various utilities used in UK for various utilities applications. It is used for remote data collection and monitoring purpose. The idea here is, but it supports easy and flexible programming. So it is used for various utilities in UK. Comstar Automotive, in the automotive industry, used our Crimson products, including HMI, so graphite series DA30. So with using this, now they are able to transfer data automatically to the central locations. Bratex Romer, which is the manufacturer of child car seats, they are using our productivity station. That helps them for minimizing the production downtime. That's it from presentation deck. I would request you to visit our stall in Industrie 4.0 and in Factory Automation Hall. We have our team available there to take you through our latest product ranges and to answer your queries. Once again, thank you very much for your time and attending this presentation. Now it is open for question and answers.
Hello, my name is Dirk Möller. I'm heading the product management team in HBK for the sensing solutions, meaning including traditional and smart sensors, ranging from torque, force, sound, vibration, weight, and strain gauges. And I would like to share with you some thoughts about new integration of smart sensors into vertical IoT platforms, which is a very strong trend to improve efficiency and connect machinery to the cloud systems. Let me share with you my agenda for today. So I would like to talk to you briefly about IoT platform strategies. What does it mean? What could be done by yourself? What could be done by external service providers? Then bridging to the cyber-physical systems, meaning where's the border from the real world to the IIoT. Thirdly, I would like to share with you some thoughts about cyber-physical systems. And here in particular, cyber-physical production system, we talk about machinery and automation. After that, I would like to share with you some examples about cyber-physical production systems and their implementation and the benefits. And after that, I would dig a little bit deeper into the smart sensor world and talk to you about the smart sensor stack. What does it mean, vertical integration, and what services and functions are needed to do so? And what does it imply for the connected infrastructure? So in this case, for machinery today and tomorrow. Where do we stand today? What benefits we can gain tomorrow? And to share with you some thoughts about that. And finally, I would like to talk to you a bit about the implementation strategy, what benefits it brings. And at the end of my presentation, I would like to summarize what we have been talking about. So let's start. So if you talk about IoT platform strategies, there are different options to do so. It could be that you do everything by yourself, so meaning from the bottom, from the infrastructure, over networking, over storage, server, runtime, middleware, the IoT platform, and also the IoT applications you can host and write code by yourself. But on the other hand, to the right side, you can also outsource this or partner with external companies. They provide you the infrastructure, the network, storage, server capabilities, and also the IoT platform, runtime versions, middleware, and operating systems. And finally, they can also provide you your application, your IoT application to show you and work for you the dashboard and the data analytics you are interested in. So a wide range from the left to the right side, and there are also some opportunities in between, some hybrid solutions where you outsource some parts of your IoT platform and do the remaining stuff by yourself if you have the capabilities. But this is a case-by-case decision depending on your environment and your capabilities and resources. And there are places and applications for each of those four architectures and structures, depending on who you are, what you want to achieve, and what resources do you have. And this is also related then, if we talk about the automation pyramid or the pyramid in manufacturing. So if we go and look from the bottom side, the signals where they are created from sensors or vision systems and where the motion and machines and actuators are driven, that is the lowest level. This is usually connected to the PLC system, which then is closely linked to the SCADA and the HMI system. And this HMI and SCADA system is closely connected to the manufacturing execution system, which is then controlled by the ERP, the Enterprise Resource Planning System. So a classical architecture found in many companies, many structures, and still the common approach to build this flow. And if we now connect and link this to modern IoT platforms, and this is just an example coming from the Siemens world. This is the MindSphere architecture, so it's quite similar to the left-hand side, coming from the field device, looking for sensors, motors, and drives, working with controllers, have the edge computing, have the MES system, connect to the cloud, and on top of that, the applications for your use case These are all part of this IoT structure and platform system. And that is very much important if you then talk talk about requirements about the field devices, the sensors, the motors, the drives. What should they provide? How deep should they be integrated, not only technically, but also business-wise into the customer's world? So meaning going above the controller and the edge computing level, maybe go into the machine execution and manufacturing execution and into the cloud and directly connected to the apps of the user. What does it mean actually? So if we talk about the physical world where the sensors and actuators are connected, that is classically the physical part of the machinery. And on the other hand, we have the cyber part. If you remember the higher levels in the pyramid, that are the network, there's the control, the information, and also the modeling of several physical properties and processes. And what you can imagine is in between there we have the sensors, and nowadays the smart sensors, the interfaces, the actors, the motion controllers, and the drives. And that is quite important because the physical part is exchanging information via the smart sensors with the cyber part, and also the physical part is controlled via the actuators from the cyber part into the physical world. And that could be not only two as shown here, it could be many. And smart sensors play here really an important role in the connection between the cyber part and the physical world. And I would like to give you an example to make it a little bit tangible. So here, this is a classical office chair. And I have the idea to make a smart chair out of it so that I can see if somebody in another room is sitting on the chair, but not only if somebody's sitting on the chair, but also who maybe sits on that chair without going to that room and check physically who is sitting on that chair. So actually, what does it mean to make a smart chair out of this standard chair? First of all, it has to have an identity, a unique identifier, how I can address this chair. So I don't want to see any chair which is occupied. I want to see exactly this chair, therefore I need an identity. Then I have to have a connection from the chair to me or to the outside world. That could be wireless, that could be wired. That doesn't matter, but there has to be a channel from the chair into the outside world and backwards. And finally, to determine if somebody's sitting on the chair or who might be sitting on the chair, I need sensors. That could be a weight sensor to determine the person's mass and the weight who is sitting on the chair, but it could also be vibration sensors, how the person is moving with the chair. That could be sound sensors. That could also be temperature sensors. So the whole bunch of sensors, sensing elements I can equip with the chair to see and to try to analyze who might be sitting on my chair. And finally, I need the data processing around the sensors so that I can process the data and build some models saying a person of this weight and with that vibration and with that temperature might be a person of a height of 1.80 meters. And then depending on the weight and the behavior of the chair, I might have a model that's saying it's my colleague A or B sitting on that chair in the neighbor room. And if I then transfer this idea to the reality, to come back to the real world, and that is already existing, this kind of cyber-physical stuff and smart solutions. So you have may heard about smart home or smart home control, where this is already reality. In the traffic world or in the smart city world, that depending on the behavior of the different participants, the system is optimizing itself. In the energy world, we talk about smart grid to connect energy consumption and energy generation in an optimal way, that you have really a good yield and outcome of the grid, of the energy generation, and also for the consumers of the energy. And finally, this is also the case for production environment in the automation world. There we already have smart sensors, and data processing in a connected factory to optimize the production processes. So, and if we talk about production and automation processes, so it's nothing where end users are involved. So it's then called Cyberphysical Production Systems. So this is a subset of the classical cyberphysical systems, so-called CPPS, Cyberphysical Production Systems. And here I have some examples how these cyberphysical production systems could look like. So from the first view, it looks like a standard machinery. But if you look a little bit deeper, and that is on the left bottom corner, you see there's a sensing element. In this case, it's a torque transducer, a rotary torque transducer, providing digital data to the control system about the status and the information of the powertrain, which is here tested, then provided to the PLC and SCADA system, and finally visualize and display the data in a dashboard. Another example here where we talk about yield and yield optimization. This is a filling machine. It's a milk filling machine, a carousel, and with very valuable liquids like soya oil, some kind of milk or ketchup. It's very important to have the right weight in the bottle, not to overfill, not to underfill. And that could be done also with a smart sensor, with the smart load cell, which you can see here on the bottom below the bottles. And this digital smart load cell controls the coarse feed, the fine feed, and controls the machine with optimized algorithm and modeling. And that is the key. So if you want to integrate digital and smart sensors vertically into the IoT architecture, you need first of all a digital connection that you are able to go from the sensor actor level with the communication path into the cloud, into the application space. That could be here, as seen, there are some HPK transducers who used to have that, digital load cells, digital torque transducers, but also many others, which are already in the portfolio, have the capability to do so. Yeah, that means actually that the CPPS, Cyber-Physical Production Systems, integrate vertically with smart sensors, because the smart sensors or the Cyber-Physical Production System acquires data via the integrated sensors and digital instrument in real time, as you have seen from the example with the filling. So it's really needed a real-time analysis, not a post-process analysis. It has to be a closed loop to control and work with the machine. But in addition to that, smart sensors also help to store and analyze data for the modeling purposes. So meaning self-adapting models who optimize themselves as many or more processes are done. So this also will help to optimize the machinery. And finally, the smart sensors in the cyber-physical production systems operate actively with actuators, human and digital interfaces, via communication interfaces and the internet services which can be provided. And that brings me to the basic architecture of the smart sensor stack. So if we talk classical sensors, we talk about sensor hardware and an external AD converter, maybe in the cabinet, maybe close to the sensor, somewhere in the cable. But with the smart sensors, there's already the digital logic unit incorporated in the sensor, so that the data processing can be done as close to the sensor. And secondly, due to the reason that it's really one connected device, the sensor logic unit is optimal, synchronized and adapted to the sensor hardware. That means with the integrated sensor logic unit and the sensor hardware, you can get better and more reliable data and sensor results than with two external units, with the classical hardware from a sensor and an AD converter or signal conditioning device with cables in between. So if you merge this together, this has actually already a huge benefit to the data quality. But that's not all. If we talk about the interface unit, so that is the example I had with my smart chair. So that is really a key factor that we have an interface unit from our digital sensor to the automation pyramid or to the IoT platform. That could be different things. That could be wired, that could be wireless, that could be traditional interfaces, that could be new interfaces, that could be real-time interfaces with high data rates, that could be interfaces with lower data rates when they just transmit events or triggers and results. And finally, if I want to really utilize the full capability of smart sensors, then I have to talk about the so-called service unit, which is then connecting seamlessly to the cloud architecture in your environment, meaning what the cloud architecture provides, like user management, diagnostics, dashboards, update of features or extension of features of the sensor via the cloud architecture. These are services which can provide additional value to the machine operator and really helps him to get more output and more yield out of the machinery. Yeah, and these are again the 4 basic blocks of smart sensors. So the logic unit, that could be simply data processing, so meaning giving out a weight or a force to the interface and then to the control system or to the IoT structure. But it could also be decentralized logic, meaning like a filling algorithm, just saying the bottle is now empty and then now it's full, and that is the status, and this is provided. And everything else, the logic is done in the operating unit, in the logic unit. But that could be also other artificial intelligence functions or machine learning to optimize machinery and to get a faster run of the machine and a higher yield and a better output. As said, the interface is an inherent part of a smart and digital sensor because the smart sensor has to connect and communicate with the outside world. There will be not only one interface, especially when we talk about IT sensors, where we really closely and easily connect directly to the IT world, so without edge devices. So there will be opening new interfaces like TSN or others or other wireless technologies to capture this trend and be there more and better integrated. And yeah, the service unit, this is really providing additional value to the user because the service units, whatever you offer, like maintenance, functionality maintenance services, diagnostic services, user management, some other messaging services, because these then could directly connect to the dashboards of the user. I call it here DB unit 1, 2, 3 or N. So because the services then really provide and closely link to the useful data that the user of the machine wants to really see. And what is the purpose of all that vertical integration? Because today machinery is not fully used and utilized, but there's also some motion which is not really bringing productivity in the machinery because the utilized motion is lower than the real possible motion. Also in the cycle time area, there are some gaps, so which allow us also to look where we have unused cycle time. And finally, we talk about troubleshooting and standstill. This is a big issue to prevent this, to have a 24/7 operating of the machinery. And with the industrial Internet of Things and the smart sensors, the operators could be capable to optimize the machine capacity. That really there is no idle movement in the machinery. That we cut the unutilized cycle time by self-adapting and negotiation mechanisms to facilitate the capacity. And thirdly, to look for predictive maintenance to prevent any ad hoc standstills, but also these intervals with fixed maintenance. So the predictive maintenance to look for case-based maintenance will be a big issue and improve efficiency a lot. But how to do so, how to accelerate this development, and there's really something what we have seen also in the examples. So from these pure centralized decision making in a PLC, in a control system. We have to go to decentralized decision making. And that could be done by using and orchestrating all the existing tools and solutions we have right now to disclose migration paths and to show a way how this can be achieved. Yeah, what does it actually mean? If I have here an analogy as an example, if you talk about classical intersection, many lanes, the classical approach would be to use your traffic lights, a centralized control system with controlling the traffic lights, and maybe also self-adapting to have an optimal traffic flow. But if we talk about decentralized, then we can talk about this roundabout where there's no centralized traffic light or control system, because each participant here, each driver, is responsible for his decentralized decision and therefore optimize the traffic flow in this roundabout. So this is the analogy also to the smart sensors in machinery. So we will have decentralized, intelligent smart sensors, which have logic functions, interface capability, and provide services to
Hello everyone, my name is Prasad Kulkarni. Let me start my presentation. Let me check if my screens are updating. Sometimes it takes time to load the pages. Yes, it's working fine now. So we are good to start. So hello everyone, my name is Prasad Kulkarni. I am from Mitsubishi Electric India Private Limited. My primary responsibility in Mitsubishi Electric is to promote our e-factory solution, which is a smart solution for the manufacturing. So you must be listening to various terms, right? Smart manufacturing, digital transformation, Industry 4.0. Similarly, Mitsubishi call it e-factory. So e-factory is a term name given by Mitsubishi Electric Corporation Japan, and we have been promoting this e-factory concept across the globe. Now talking about our corporate strategy. So our corporate mission or our corporate strategy is to improve our technologies and services by applying creativity to all aspects of our business. And while doing so, we try to enhance the quality of the life in our society. We have been serving to various business verticals. One is the life, where we have AC systems, VRF systems. We are also into industrial division, where we belong to, that is factory automation industrial division. We also have infrastructure division, where we have solutions like lifts and escalators. We also have a mobility solution, where we provide solution for metro transportation system. Now talking about our industrial automation division, we call it FAID, Factory Automation Industrial Division, where we have various automation products, right from PLC, HMI, drives, mechatronic products, rotating equipments, LVS products, and to support e-factory concept or Industry 4.0 concept, we have a series of products called industrial computers. We have a mail IPC series. MI5000, MI3000, that and which is powered with our open software platform, that is HCross. We also have some software packages. Those are ready-made software packages. You can call it pre-configured software packages. Those are like IQ Monozukuri or eFactory Starter package. Now talking about digital transformation in the manufacturing. So you must be aware we are currently experiencing industrial fourth revolution. So Mitsubishi Electric has correlated all these industrial revolution with a point of view of society. So we say we are currently experiencing society 5.0, which is about the creative society and which is about completely human-centered and problem solving. So we say we started with society 1.0, which is about the hunting society. Then we got into farming society. Then we shifted to industrial society, then information society. But currently we are experiencing creative society, which is about the information, which is completely human-centered and problem solving. Now talking about environmental changes in manufacturing, there are various advancements happening. The way we collect the data, the way we communicate the data, the way we process the data, and the way we analyze the data. We have been analyzing, collecting data, communicating data from last few years, right? But there are some advancements happened. Like if I talk about data collection, then talking about sensor, we have a sensor which gives 420 milliampere, and that goes to the PLC, then it goes to some visualization software or the product. So now people are expecting that sensor data to be directly provided to the cloud platform. So there are some sensors available in the market with IoT gateway. Of course, there should be IoT gateway in between, but it can directly give data to the IoT platform. So sensor will directly give data to IoT platform using IoT gateway. Then if you talk about the data communication, then there is a network technology in the market, which is about the TSN, which is a time sensitive network. And for talking about data processing, then we process data over edge and over the cloud. Now this slide talks about basically environment surrounding manufacturing. So you can see this slide will give entire 360-degree view of manufacturing, but our focus, our eFactory focus, is only for the manufacturing solutions. So since we are talking about manufacturing industries, so there are certain challenges. So challenges are like there are some non-standard processes and user interfaces. We have seen in a manufacturing environment, there are a lot of data sources which are legacy data sources. These are some proprietary data sources. So collecting data from those data sources is again a challenge. So to provide data in a seamless manner is a challenge. Then there's a labor shortage. When I talk about labor shortage, so here I'm talking about skilled labors. So we have seen in manufacturing, there are various tasks which can be handled using robots, but those are being handled by human. So this is the gap which can be fulfilled using our eFactory solutions. Then there is another challenge. What we see is the processing, passing down the established skills. So when I talk about passing down established skills, that means we have seen in the manufacturing industry, there are very limited resources which are very skilled, and if they leave the organization, then the organization face problems in terms of maintaining the particular machine. But by using augmented reality kind of solution that is available with as a eFactory solution, those challenges can be met. So in a nutshell, I would like to say eFactory is a comprehensive solution which addresses all the manufacturing industry challenges. Now talking about our Mitsubishi Electric solution for manufacturing, that's the eFactory. And if I want to define eFactory, then I would simply say eFactory is a comprehensive solution that leverages latest digital technology like big data, IoT, edge analytics, advanced robotic solutions, simulation softwares, and we try to build a technological ecosystem that help our customer to achieve digital transformation in their manufacturing environment. So this eFactory concept launched in 2003, and as the technology is emerging over the period of time, we are also evolving our eFactory concept. So if you look at on right hand side this particular architecture, you can very well correlate this architecture with ISA 95 architecture. And while we provide e-factory solution, we also realize over the period of time, alone Mitsubishi cannot provide each and every solution. For that, we have various partner associations with us. So we call it e-factory alliance partners, where we have 3 categories of partner. One is software partner, SI partner, and device partner. So wherever there is a gap in our solution, we try to get help from our partner. We try to use their solution, use their expertise, and provide an end-to-end solution to our customers. So this slide basically talks about our experience and journey of e-factory. So as I mentioned, we started in 2003, and as technology is emerging, we are also evolving our e-factory concept over the period of time. So we have implemented our e-factory concept in our own plant in 2005. That is our model factory. So here we have deployed our e-factory solution. The location is Nagoya, Japan. Then we implemented our e-factory concept in Fukuyama, Japan. Then we implemented this in Kani, Japan. Then in Gunma, Japan. And somewhere in 2015, we have been awarded by Frost and Sullivan for Best Practice Award. Then somewhere in 2017 was a year of innovation for us, because we launched various technology. We launched our network technology, that is CC-Link IETSN. We launched our MySAT AI technology, which is a proprietary AI technology, and we launched our H-Cross open software platform. And somewhere in 2019, we announced our e-factory alliance meet in India, and we started our e-factory solution promotion in India. So that was overall journey. Now talking about our MySAT AI technology. So MySAT is basically short form of Mitsubishi Electric AI creates the state of art in the technology. In this AI technology, we use basically machine learning algorithms, where we have developed various machine learning algorithms using deep learning, strengthened learning, which is about the reinforcement kind of learning. And we have been applying these machine learning algorithms for the big data. So while we deliver our e-factory solution, we try to keep our solution as standard as possible. For various layers, we use our own products. For control technology, we use our programmable controllers. We use our industrial robots at level 1. For IT/OT integration, we use our own products like MES IT interface card, which is nothing but a database connectivity. Then we have our OPC UA server module and our edge analytics products. And for the network technology, we have our CC-Link IETSN. This is a general architecture of our e-factory concept. So you can see we have been implementing e-factory concept at all the layers of manufacturing, whether it is level 1 or the level 4, that is ERP. And it can be implemented across various factories. Now talking about e-factory value proposition, the promise we deliver, the promise that we make as a solution provider. So we have solution for data visualization, augmented reality and digital twin, edge analytics, and advanced robotic solutions. So before we talk about our value proposition, let's talk about our solution capabilities. So here I would like to visualize entire manufacturing. So you can imagine this is the shop floor where you have various FA devices. So these FA devices could be automation system. It could be automation system from Rockwell. It could be from Siemens. It could be from Mitsubishi, from Schneider. So irrespective of your make and model of the shop floor data source, we can collect the data through various ways. So there are various ways through which we collect the data. One is through hardware gateway, where we use our own PLC product as a data concentrator. And another way to collect data is through the software gateway, where we have software drivers available to collect the data. So once data is collected, then there is a data visualization where we use our Iconics suite, so which provides solutions like equipment-wise data, material management, workforce performance tracking, digital twin, augmented reality, production planning and control. Then we have another solution called edge analytics, where we can do real-time data processing, data analysis. We can use machine learning algorithms, and whatever data we process, that can be given to any third-party big data analytics platform, whether it is from Microsoft Azure, whether it is from IBM Watson, or any other IoT cloud platform for that matter. Now talking about data visualization. So these are some sample OE dashboards created using our data visualization platform, that is Iconic Suite. We use our KPI Works product, and there are some sample widgets through which we can develop dashboards for depending on the roles and responsibility of the user. So when we use our data visualization platform to upper system, that is at level 3, so we can offer solution like production planning and scheduling. The solution can be used for maintenance management, it can be used for quality management, it can be used for traceability purpose, it can be used for mistake proofing visualization. So these are some sample dashboard which we have used for daily production plan. Here you can see this histogram for the quality analysis, and whatever data we are visualizing, it can be visualized on any glass, whether it is your desktop PC, whether it is your laptop or mobile screen. When this data visualization platform connects to level 1, it gives you equipment-wise parameter monitoring, trends, alarms, alerts, and notification. It also gives you machine workload and availability. It helps you to get reports, generate reports like batch-wise, equipment-wise. Quality analysis is possible. When this connect to utilities, you can monitor your utilities. The utility could be energy, water, gas, steam, anything. Now this solution about the augmented reality, which is one of the popular solution nowadays in the industry we see. So we have augmented reality solution in our product basket. So I would like to just run through a small video which will give you more idea about this augmented reality solution from Mitsubishi Electric. So here you can see this is a device, and we have been using this Microsoft HoloLens. Through this Microsoft HoloLens, we have been visualizing and scanning this particular device, and this particular person is doing maintenance activity. So this augmented reality kind of solution can be useful to perform remote maintenance activities. It can be used for optimum resource utilization, which solves problems in a more quicker way, and it gives you greater user experience. Another solution is the digital twin. So we offer this digital twin solution using our Iconics suite product, where we have facility like where you can import CAD files of the equipment. A complete virtual operational model can be created using Iconics suite, and the benefits could be maintenance on demand, reliability prediction, then improving operational efficiency and reducing downtime, and the quality improvements. Now talking about the next solution, which is about the Edge Analytics solution from Mitsubishi. So this is the solution where we use our mail IPC MI5000, and this solution is being powered by our Edge Cross open software platform. It offers cloud connectivity with Microsoft Azure, AWS, Google Cloud, IBM Watson, and it offers solution like analytics that realizes increase in production efficiency, quality improvements, preventive and predictive maintenance. So basically in this solution, we use our RDA product, that is real-time data analyzer. So this analyzer basically help to do real-time analysis of the solution, of the manufacturing data. The next topic is about the advanced robotic solution that we offer. So here you can see, there is a robot which is basically collecting data from these parts from this bin, and at the same time it is basically avoiding the obstacle which is in between as a human, and it is identifying the place where it has to place this component. So I will just run a small video for your visualization, for your better understanding. So here you can see this particular robot has identified the obstacle, and it has collected right product, and it has placed at the desired location. So here we have used our MySAT AI technology with this industrial robot. Now talking about overall solution delivery method. So while we offer any e-factory solution, we have various teams that are involved. One is the digital transformation team, that is project execution team. Then we have our e-factory sales and marketing team, and we have our alliance partner. So this is about the comprehensive solution approach that starts right from planning and analysis, where we listen and refine the customer's requirement, detailed design, implementation and installation, testing, training and handover, and support and maintenance. This is the final slide. Why choose Mitsubishi Electric? So we have rich pool of experienced professionals. We have manufacturing domain expertise, whether it is a pharma, whether it is a automotive or F&B. We also have good support ecosystem. We have local and global technical support team. Then we have network of 80 plus channel alliance channel partners. We also have various alliance partner across India. We have FA training centers at 6 locations. We also have our R&D center, and we are basically driven by latest innovation and technology. So that's all about our e-factory solution. If you have any questions, you can come back to us. You can simply put your queries and we will be happy to answer. Thank you very much.